Hey Miss Hamill, how's it going? I'm going to take you through what I'm doing for my simple harmonic motion project. So what I'm going to be doing is I'm going to be investigating the different factors that affect the period of oscillation of a spring, or in this case an elastic material like the one I've got here. I'm using resistance bands. And so what I'm going to do is I'm going to alter a few different key variables. I'm going to be altering the amplitude of oscillation, the mass attached to the resistance band, and then the elasticity, or I guess you could say spring constant, of the resistance band. So I've got a 2.5 pound plate as well as a 5 and a 10 pound. I've got the resistance band up there, which is labeled light. I've got this one labeled medium. And then so I'll also just be doing trials where I do different amplitudes. So this is what it's going to look like. I'm going to basically pull it down to a certain amplitude, time 1 and 2 oscillations. And as you see, after 2 oscillations, it gets pretty unstable, so that's why I'm only going to use 2. I'm basically going to take that time and divide it by 2, and that's going to be my experimental value for the period. I wouldn't do more because it seems as if the system gets pretty unstable after 2 oscillations. And then so basically that's what I'm going to do for my data table, and then afterwards I'm going to solve for the spring constant, I guess you could say, of each resistance band. So I've got the light one and then the medium, like I said, and that'll be my graph. So basically I will plot the period of oscillation against the square root of the mass and do some rearranging of the variables that are in the period equation for a spring to solve for the K constant. And then so that'll be my project. I hope it does a good job of explaining the variables that affect the period of oscillation of a spring. And that is all. Thank you very much.